Okay, welcome everyone. Thanks very much for coming. This is What's New with Dart, your first class upgrade to web development. My name is Seth. I'm a developer advocate with the Dart team.
And I'm Justin Fagnani. I'm an engineer on the Dart team working on tools and libraries, and I also help internal teams move to Dart.
All right, real quick, what is Dart? Well, Dart is much more than a language. It's also a set of rich libraries, very productive tools, fast runtimes like a virtual machine, but probably most importantly, Dart compiles to JavaScript. So you can write a Dart app, compile it down to modern JavaScript, and run it across modern browsers like this today. We like to think of Dart as batteries included package for you. OK, so this is a real-life story from a developer just like you guys out there. He works for a bank. He has to write a lot of web apps. So he's telling me, this is true. He's saying, OK, the other day I was asked to build a new web app for my internal customers. So hi, I want to build a web app. First off, you need to go get required JS because you need some sense of modularity. You need to get Backbone because you need some sense of client-side infrastructure. You need to get Backbone Marionette because, of course, you need some extra functionality. You need to get jQuery because every web project uses jQuery, whether you like it or not. Somebody uses it. You need to get Modernizer because you need to do feature detection. You need to get Moment.js because you need to deal with dates, parsing dates, formatting dates. You need to then get Dest templates because you need some sense or some solution for client-side templates. You need to get Phantom.js because you needed some sense of browser-based testing. Then you needed to get Jasmine because you need to actually write those tests. Then when he's got this teetering pile here, of course, then he finds out that every one of these projects has a completely different set of formatted docs. So you got to find those and read those and figure those out. And then you need to finally integrate this entire pile here to make some semblance of a working system. The interesting thing here, though, is that not only do you actually have to wire it all together, but some of these solutions offer duplicate answers to the same problem. So you got to kind of reconcile that. So after he built this kind of teetering pile here, quote, I just want to build web apps. So then he found the Dart project, true story. He was able to replace the teetering pile with simply just the Dart SDK and 3 packages that he could just download with our package manager. And quote, thanks to Dart, things are consistent and clear. So this is a good example of a real-life story of a small team that needs to move fast, and their experience using Dart. But that's an external small team. Justin, how's our internal teams doing?
So like I mentioned, I help internal teams adopt Dart. And at Google, we build a few web apps. And some of them are quite big. To give you an idea of how big they are, our teams can be from dozens to hundreds of engineers. And we can easily have millions of lines of code. And over the years, our engineers have determined that they need tools to help them manage this complexity and basically maintain their sanity to be able to work with such large amounts of code and large teams. So they've built tools like Gwt and Clojure and Soy. And these tools do different things to help them kind of guarantee correctness and behavior of the applications. They introduce modularity and structure, classes, maybe some type checking. Gwt introduces Java as the source language. And these tools have been very successful in that they help teams write these complex apps and actually get them out the door. But they have some downsides. In particular, all JavaScript at Google is compiled. And this means that we've introduced a compiler into the development workflow. And that can significantly slow things down. With these large apps, the compilers can take a long time to run while you're trying to develop your app. So we've started moving some teams to Dart. And with Dart, we try to fix that problem.
I want to point out real quick that this is real feedback from internal teams. 24 minutes sometimes to see a change. Can you imagine iterating at 24 minutes per change?
I've done that.
Surely we can do better.
Right, so surely we can do better. So what we've done with Dart is we've tried to kind of address these issues to fix some of the problems with the structure and the semantics of the language, but also not have the downsides. So here we have a chart that kind of shows some different projects out there that are compiled to JavaScript projects. So we have Gwt and Clojure here. I'm sure you guys have heard of CoffeeScript. And also Microsoft has their own compiled to JS project called TypeScript. And we've kind of roughly said whether or not they hurt and help on these different dimensions. And we feel like Dart is finally a solution that we have that helps on every dimension. It actually improves the development cycle while also giving teams the safety and semantic improvements that they require.
One thing I want to point out on this slide, actually, I think it's really important to understand this requires compilation for development. Notice how Dart does not require compilation for your very fast iteration development cycles. We'll see how we make that possible in a little bit. OK, cool. So before we jump into all what's new across the whole Dart platform, and there's a lot, we want to give you a quick lightning tour across the syntax, semantics, and structure that Dart offers so we can show you a bunch of code samples throughout the talk. Let's start with the syntax. First up, very familiar, classes, semicolons, curly braces. I think everyone can read this code. Dart's very terse. We like to say it's ceremony-free. Here's a good example here. What do you always do in constructors? But this.x equals x, this.y equals y, etc. This is getting boring. So instead, you can say if the constructor parameter name is the same as the name of the field, you can simply say this.strength here. In this case, eliminate some of the ceremony or boilerplate that you typically have in other languages. Name constructors, one of my favorite features here. Obviously, methods, you can name pretty much whatever you want, but constructors typically are always named the name of the class. That's a little bit constraining, so Dart offers name constructors. Here, I can say new hug.bear and set up a bear hug. It's very clear. I totally understand what I'm creating when I use these name constructors. Dart has operator overriding. Here's a good example of that. Named optional parameters, another one of my favorite features here. So the curly braces here turn on a couple things. First, this becomes an optional parameter, so you may or may not, or you can or cannot pass in a parameter there. It's named in that I understand what this number is, so hands, and I get a default value of 1. So again, features that normal scripting languages have, Dart has as well. Some of my other favorite features here, fat arrow syntax for your simple one-line functions here. This is just syntactic sugar for curly brace, return, expression, curly brace. Dart uses one-line functions a lot, especially in inline anonymous functions, so they're really useful there. And finally, string interpolation, a very simple way to build up strings based on variables or expressions.
OK, but Dart isn't all just syntax improvements. Dart is its own language, and it has its own semantics. And I'm sure some of you have heard of the JavaScript whats out there, these surprising moments, what in JavaScript, or the Java puzzlers. So these are confusing parts of the languages we're familiar with. And we try to improve on that, too, and turn our whats into some kind of atomic rock dinosaur thing, but awesomeness in general.
I want the one on the right.
Yes, me too. Looks more fun.
That one's scary.
OK, some examples of semantic improvements. Just real quick, only true is truthy. So you don't have to guess what values are going to be true or false. Basically, true is true, false is false, and everything else is what it is, right? We got rid of undefined. There's only null. That fixes a lot of problems. There's no type coercion with equalities checks or operators or other things like that. So the language is more predictable in a lot of ways. Some other examples. In JavaScript, if you access a property that isn't available on an object, you will get undefined, right? So that can be a problem if you have a typo. You don't necessarily know it. You just get an undefined value. So in Dart, we change this, we fix it, and what do you think happens here, Seth?
Well, hopefully a clear and consistent and logical error.
Well, that's exactly right. If you access a missing property on an object in Dart, you get a no such method error because Dart knows it doesn't exist because it wasn't declared. Let's look at list access. So here we have an empty list, and we're accessing the 99th element of an empty list, so we're way out of range. What do you think happens here, Seth?
Hopefully a clear and consistent and logical error.
Amazing. You're right again. Here you get a range error like you would expect. This has a number of benefits to your program and the VM. Next, let's talk about scope. So JavaScript, as you might know, has function scope, and it hoists the function declarations to the top of the function. So here we have two variables with the same name, foo. One of them is a top-level scope, and the other one is inside of this block here, inside the if statement. So when we print foo here, how do we know which one is going to be printed? Well, so we call this method here, and it's going to print something. Seth, what do you think it prints?
Hopefully, due to the logical static analysis I can do with my own eyes here, top level.
Seth is a ringer. Yes, it does print top level. These things are less confusing, less surprising, and better for development. This also. So we have lexically scoped this. This is bound to a lexical scope. You always know what this is going to refer to. In DOM programming, for example, the this pointer of an event handler actually refers to the function that's the event handler, not the object that you're in when you define that function. And there's libraries that try to fix this. But in Dart, we've just gone ahead and fixed it for you. So in this case, this refers to our instance of awesome button, and it calls the right method. And it's just very unsurprising.
OK, so that was the syntax, a little bit of the semantics. Let's talk about the structure. Now, we've seen functions and classes, and we'll see some of these other features like Mixins in a little bit. So let's talk about libraries. Dart has a really nice way to bunch up your code into reusable chunks we call libraries. Here's an example here. This is a single file. You simply declare that a file is a library using library games here in this case. You can import other libraries. Dart:/math comes from the Dart SDK. Players.dart is another Dart file, so we can pull in other files as libraries as well. And a feature I really like is you can put, say, multiple classes, top-level functions, all in the same file. So it gives you a very flexible way to organize not only just where you want to put your classes and functions, but also how you want to structure them on the file system. But everything falls inside a library. You can then import them and reuse them. OK, that was the lightning tour. Let's look at some of what's new. Let's start with the language. All right, here's a common thing that you always do, say, working with the DOM. You want to create a new button and set up the state of that button, ID, text, classes, click handlers. Well, in this particular case, I've repeated button 6 times. That's a lot. Well, taking a cue from Smalltalk, we've introduced method cascades. And in this example here, I've eliminated the repetition of the variable button. See the double dots here? All of these expressions are applied to this very first expression here, new button element. I've eliminated most of the occurrences of button here. I like this for builder type APIs. It makes it just more clear and concise. We can do a little bit better. Because all of these different cascades roll up to this first expression here, I can actually eliminate the need to introduce a new variable. So here you can see I can add this new button element to the children of this parent element and initialize its state all within the same call here. This is really
one great thing about this is that it turns every API into a builder API. So you don't have to preemptively return this from all your methods in order to have a fluent API. In Dart, every API becomes fluent, and it's universal across the board and consistent. OK, so let's talk about another great new language feature called Mixins. So Mixin is something that languages like Newspeak and Smalltalk have. And it's a way to share code without using inheritance. You might be familiar with the maxim composition over inheritance. And the idea is that there's problems if you try to share code exclusively through inheritance. You can only have one superclass, so it might not be a class you actually want to extend. So in the last year, Dart's added Mixins. And let's take our Hug example from before, and let's say we want to save it to a database. A typical solution to this is you extend some kind of persistable base class. But that has a lot of problems. You might want to extend some other class, actually, right? So what you're interested in here is the behavior, not necessarily the inheritance hierarchy. Hug is not actually a persistable. It has the persistable behavior. So you don't want to pollute your inheritance tree. Instead, what you want to do is just add this behavior. You want to compose it or slide it in from the side, the persistable behavior. So what does this look like? Well, up top here, we have our abstract class persistable. And in save and load, we define the behavior we want, the implementations and the ... dots there. And we require the classes that implement persistable implement this toJSON method. Once they do that, save and load can use that method in order to implement their behavior. So down here in our Hug class, we're going to use the brand new keyword with to say that we want to mix in the behavior from persistable into our Hug class. And then you'll notice that we define that toJSON class, which is used by the other methods. And then at the bottom here, you can see that we call the save method. That's been added to Hug. It's not inheritance, and it behaves as you would expect. So this is a great way to compose classes together. You'll also notice that persistable is just a class. We don't have like a mix-in keyword. So there's just a few restrictions. If your class extends object and it doesn't have a constructor, then you can use it as a mix-in. And some of these restrictions might go away over time. So. Oh, we had animations. All right.
Another new feature are metadata. Here's a good example. You can use metadata with the @ symbol here, @deprecated. And that gives really good feedback to, say, tools. In this case, the Dart editor, he can look at @deprecated and then visually indicate the functions or methods that are deprecated. The nice thing about metadata in Dart, though, is you can define your own metadata. Here's a good example of an in-progress feature we're working on, lazy loaded libraries, that uses const objects as metadata annotations. Let's try to walk through some of this code. So first, we're going to declare that the library itself is deferred. And we're creating a const object, const lazy. We can then use that lazy const object to mark the import as lazy, as shown here. Then we can call load on that lazy const object, the deferred library, and use a future to wait for that library to finish loading. Then we can use the features and functionality from that library inside of the future. Now, our tools can read these metadata annotations here and say, take in Dart applications spread across multiple files, pipe them through Dart to JS, which can look for these metadata annotations and spit out a single JavaScript file for the bulk of the app, and then another JavaScript file for that lazy loaded library. This is a great deployment time tool for you to choose how and when you want to load in the different components of your application.
OK, so that's what's new in the language. Let's talk next about the libraries. There's been a lot of great developments in the last year. First, let's talk about the #1 question that we get asked with Dart is, can I use existing JavaScript libraries? Can I integrate with JavaScript in some way? And the answer is yes. We do this through our JavaScript Interop package. Now, Dart can exist in 2 different worlds, really. We have this Dart to JS world where everything is compiled to JavaScript. And also in Dartium, we have a world where there's 2 different VMs. And so you don't always have direct access to the objects. So the way JavaScript Interop works is that we use proxy objects. And these proxy objects represent an object that's in the other environment. And the calls are forwarded, data is serialized as necessary. So let's show an example. So here we're using the JS package with a prefix, JS. We have code up top in Dart and down below in JavaScript. And we're going to use an imaginary charts API. You can see that the code looks very, very similar. In the first line, here, we're just stashing a reference to the API object. In the second line, we need to create some data. Because our charts API is a JavaScript API, and we need the data to be a JavaScript array, we simply pass a Dart array to this function that creates a JavaScript array out of it. And then in the third line here, we want to create a new chart. The way you do this from the Dart world is you say, I want to create a new proxy, and you tell it what constructor and what arguments to use. A little bit different, but looks very similar to the line below. And then finally, chart is now a proxy to a JavaScript object. And now you can interact with it in a way that looks very much like any other Dart object, and in fact looks identical to the JavaScript below. So with the JS-interop package, you can use JavaScript APIs. This is very important for existing applications.
Another new library we've been working on over the past year is our mirror-based reflection library. With mirror-based reflection, you can do source code and runtime reflection. That is, you can load up a bunch of source code and use mirrors to ask questions about it. You can also, at runtime, ask questions about the structure of your app. You can use mirrors to reflect on both classes and instances. And you can introspect, say, what fields do you have, what constructors do you have, and invoke methods on those objects dynamically. How might we use this? Well, here's an example of creating a logging proxy. Say I have some client code that wants to call hello on some object, but I want to go through a proxy that logs all these calls. So it's going to hit proxy first. He's going to print out some sort of logging statement. Then he's going to delegate the actual hello call back down to the true delegate object. Let's see how we do this with mirrors and reflection. So first up, import the Dart mirrors library. It comes to you from the Dart SDK. Next, use the top-level function reflect to reflect on the delegate object and get back an instance mirror. Next, now remember, if you call a getter or function on an object and that doesn't exist, you'll get a no such method error. It's nice, clear, and concise. You can actually implement no such method here and capture those calls and do something dynamic and interesting with it. In this case, we're going to do that to capture all calls going through our logging proxy. Before we actually delegate, let's go ahead and log that call out. We'll just print it out very easily. And then using that instance mirror itself, we can delegate the original call that came in from no such method and pipe it into the actual delegate itself. This is a really nice way to deal with runtime dynamic programs using no such method and mirrors. Here's the example. We're going to create a logging proxy, wrap greeter. We're going to call the hello method on what we think is the greeter, but of course it's going through logging proxy. 2 things will be printed out. First, symbol hello was called. That comes from the logging proxy. And then hello, that comes from the greeter because we delegated that call back down to the delegate.
All right, let's talk about something that's very important for web programming, which is asynchronous APIs and asynchronous programming in Dart. Dart's had some facilities for asynchronous programming, and they've been greatly expanded in the new Dart async library. First of all, why is async programming so important? Why is it such a big deal for Dart? Well, the web is full of asynchronous APIs. These are the APIs that when you invoke them, they don't block your program, and they go do some work in the background, or maybe they wait for some event to happen. And they need to notify your program when they're done, so they take a callback. And when they've loaded some data or a user clicks on a button or something, the callback is invoked. If you need to perform some data after that, then you need to call perform another asynchronous operation after that. You need to call another API in the callback and then register another callback. You end up with these nested callbacks, which leads us to what is known as callback hell. Well, With Dart, we've tried to add features to the libraries that make your life easier and lead you from callback hell to callback nirvana or callback tropical
Beautiful
beach.
beach.
Yeah. And we do this with futures and streams. So first, let's take a look at futures. So a future is a promise that there will be some value delivered to you at some time in the future. In fact, in JavaScript libraries, the concept is often called promises. So first, let's look at a callback example here. DoStuff is an asynchronous method. It takes as a first argument a callback that will be invoked when it's done, and as its second optional method, an error handler. So this is what a callback-based API would look like in Dart. And as you can see, even with a simple one-level deep, no nesting, it's already looking a little complicated. Well, with futures, what you do is instead of taking a callback, you return a future. And this future object has a very consistent way of registering the callback and the error handler. All futures are the same class. They all do this the same way. And you can see it already looks a little cleaner. But because futures chain, they return themselves, you can make this look even simpler. You don't actually have to store the future in a value. And in fact, in Dart, you often see code that looks like this. You call an asynchronous method, you register a handler, and you register a callback. And it looks very sequential.
We should point out here that handle and handle errors themselves are functions. So we can pass in a function right into these callbacks without dealing with a whole one line or multiple line like what you see on the left.
Exactly. All right, now let's look at something where we have more than one level of nesting. So here's an imaginary cat service, because we all know the internet basically exists for trading cat pictures. So the first step we do here is we get some cat data. And once we get the cat data, we're going to want to go get a picture. And then once we have the picture, we're going to want to rotate it in some worker. These are all asynchronous calls. And finally, 4 levels deep, we do the work we wanted to. And you can already see that the control flow here is hard to follow because it's based on the nesting and where the arguments are. But it gets even worse. Now imagine you want to do error handling. And if these methods each take an error handler, then the error handlers get a little bit separated from the callbacks. And if there's actually real work being done in these, if they're not just one-liners, this becomes very complicated to follow. But if you imagine the same example with futures, it becomes much simpler. With futures, the errors are propagated through them, and you can chain them with different asynchronous calls in a row, and you can make that same nested callback structure look like a sequence of events. So this is where futures start to show some big advantages in terms of clarity of the code.
When you say the errors propagate, so an error or an exception can happen on any one of these calls to then. It will bubble down to that one catch error.
Exactly. You don't have to register multiple error handlers. You can just, it's almost like a try-catch block, but asynchronously. OK, so that's not all, right? So futures are nice and consistent, and they clean up the code structure a little bit. But futures also compose. Futures like a first class concept of there will be a value in the future. And you can write utilities that deal in futures. And one of the most basic utilities is just waiting for things to happen in parallel. So future has a static method on it called wait, which takes a list of other futures. It waits for them all to complete and returns a new future when it's done. And so this is a very easy way to wait for parallel items. You can imagine in JavaScript, you usually have to keep some kind of counter of how many callbacks have finished and update them, and error handling becomes difficult. Well, here it's all done for you. You just give it a list of futures. Here we're getting 2 pictures, and we want to blend them, and we still have an error handler down at the bottom. So we work with both pictures. I'll go back. And notice that the error handler will work on the futures that are happening in parallel and every subsequent operation. OK, so futures have been around for a little while, but what's really new in Dart is streams. So futures only fire once, but you also have to worry about repeating events, things like user interaction with the UI and I/O. So streams are the new thing, and they are the repeating analog to future. And in the Dart libraries, because we get to start fresh, nearly all repeating events in Dart are streams. You should see very, very, if any, little callback-based APIs anymore.
I think that's an excellent point. With futures and streams, we bake them across the APIs and libraries that we've built. So everything from, say, opening files to XML HTTP requests to get user media to the file I/O, the directories.
All your basic
DOM
now
events.
Is
futures and streams. And you get that because we bake it into the SDK for you.
And because we got to start fresh with the libraries, too. All right, so let's take a look at an example. Here, we're going to look at the documentation for the element class. This is the base class for all the HTML elements. And you can see that there's this line here that says, on key press as a property that's a stream of keyboard events. So what does that mean? It means that we can do like a query here for a text area. And we can access this on key press property and call listen, which is very much like then on a future. And the function given to listen will be invoked every time that there's a key press event, and it will be given that event. So here we simply turn our key press event into a string and print it out. So this will print car equals whatever we happen to type. But streams do a lot more. They have a very, very rich API. You can filter the events, you can transform them, you can turn streams into future by getting like the first or last element in a stream. So here's an example where we want to get our key press event. And let's say we only care about events that are actually like keys on the keyboard that you can type and read. So you might want to filter these to get rid of control characters and things. So here we can just filter the stream, and we use some range filter to say these are our valid characters. And this returns a new stream where we can call listen or more transformation methods on them. And next we're going to call map. And what map does is it takes every element, every event in the stream, and it turns it into some new kind of event and creates a new stream out of that. So here we're going to map and turn our keyboard events into strings. Finally, let's say we're only concerned with the very first key press in our text area here. So we can call first on the stream, and that returns us a future now, which returns a value when that key is first pressed. And then we can call then like we did before, and we can print out that the first character is that character. And you can see that this reads really nice, and because streams are so common across the libraries, you'll be able to see and recognize these patterns across Dart code bases. Okay. Finally, this is a relatively short talk, so we don't have nearly enough time to go to HTML and web components. There is a talk later at 3:30 with Emily and Seth, and they're going to go deep into the new developments in HTML and web components and how you develop rich, complex UIs in Dart. A lot of changes in the last years that we've Dartified the HTML library. It follows Dart idioms, uses Dart collections, and gives you some jQuery-like functionality. We also have Web UI, which is our custom elements implementation. We've done things like gotten rid of vendor prefixes, so you can just use one method call. So that's at 3:30 in this room. Yeah.
OK, cool. Let's look at what's new across the tools and ecosystem here. Well, one thing that's really important to point out, and we alluded to this earlier, is that the development cycle in Dart is very, very fast and very quick and iterative. This is important for web developers who are used to simply making a change and hitting reload in their browser. They want to see that change immediately. They don't want to be slowed down by any sort of compile time process during the bulk of their development. So I'm happy to say that with Dartium, it's a special build of Chromium with the Dart virtual machine embedded inside, we can deliver those very fast, no compiles required, edit reload cycles. So typically the flow will look something like this. The feature or bug inception. Throughout the bulk of the development, you're simply writing code, hitting reload in Dartium, boom, you see the change right away. Only right at the very end, and this is what we've been told by real users of Dart, only at the very end will they introduce Dart to JS, compile their application into JavaScript, and test on all of the browsers. So this is really, really nice. We've also been working on a standalone editor called Dart Editor. This is built from the ground up, built on the Eclipse platform, to give you features and functionalities you're used to when you develop code and apps on all other platforms. Things like refactoring, things like jump to definition, inline types, a nice problems view. The list goes on and on. This is the kind of productive development experience that you like when you deal with code as you grow from 1 to 10 to 1,000 to, say, 500 or 1,000,000 lines of code, which is not unheard of when you build the kind of apps I think users are demanding. But if Eclipse isn't your bag, that's OK, because we've also got plugins for Vim, an actual plugin for Eclipse, as opposed to Dart Editor, which is a standalone editor. Plugins for Sublime, and our friends IntelliJ and WebStorm, they're actually up there in the Chrome booth, can show off their Dart plugin as well. So hopefully we've got a choice for you across whatever editor you are working with. Now, we'd love to show a demo of this, but we have something really new and exciting to show you guys in terms of editing Dart. We're happy to announce the relaunch of try.dartlang.org. that our team's been working on. We've taken the Dart to JS compiler, compiled it with itself into JavaScript, put it in a browser, and giving you the ability to write Dart code and see it live without having to install anything. So let's take a look.
All right, let's check it out. Yay. OK, so this is try.dartlang.org. As Seth mentioned, this is using Dart to JS, which has compiled itself to be able to run in the browser. So this is the same compiler that the editor and the command line applications use. So here we have a simple little text editor. Notice we have some syntax highlighting happening here because of Dart to JS. We're going to change this to hello Google I/O. And notice it's compiling on the fly. And there we go. We see the output. Also notice that this is running in Firefox. So it's important to note how critical Dart to JS is to the deployment step here and how much it enables Dart to run on all of the modern web.
Nice improvements also is this works offline, this works on your iPad, and you can also edit HTML apps as well. So very nice way for you to try Dart and then go pick an editing experience that works for you. OK, what else in tools and ecosystem? Well, we have a nice unit test library that comes out of the box. We also have a mock library that comes out of the box. Here's a quick code sample here at the top for our unit test. Looks familiar. I think a lot of other unit test frameworks you might have seen before. Also happy to announce that we have a headless version of Chromium we call dump render tree. But this allows you to run HTML-based Dart tests in a headless browser and then take that and wire it into continuous integration services like Drone.io, who have native support for Dart and this headless Chrome. So you can check in your code into Bitbucket or GitHub, fire off a change, which Drone.io picks up, runs all of your tests from the command line, runs all of your HTML tests or web tests in this headless Chrome, and reports back to you how everything's working. So you now start to see this nice chain for a really rich kind of end-to-end development experience. Also been working on a package manager we affectionately call Pub, because you play darts in a pub. And with Pub, you can download packages, manage the dependencies and the updates, publish your own packages to Pub, and browse around pub.dartlang.org, which is our hosting service, where there's already over 200 packages out there ranging everything from database drivers to MVC frameworks to encryption to parsers, game libraries. The list goes on and on and on. And it's very easy for you guys to publish your own packages into Pub as well. Pub works with our central hosting service here, Git, local file system, very easy for you to reuse and send out and share functionalities across Dart apps. We're also really happy to announce that the Flash Pro, the really rich animation game editing tool from Adobe, now can export your animations and games to Dart. And you can see a demo of this up at our booth up in the Chrome area. So real quickly, you don't have to write any action script. You can use the really rich editing experience of the stage and the timeline and all the asset managements of Flash Pro and go through their toolkit here and export that all out to Dart code and HTML5 APIs, which means you can use their really slick tools here and then deploy that across the modern web without any plugins at all. So if you guys are interested in this, come check this out upstairs. OK. Next, let's talk about things that are very important to web developers, size and speed, or performance. The web has gone on a continuous evolution path since it started. And one of the things that's happened with JavaScript is that it initially enabled the very first client-side apps. And JavaScript wasn't that fast. But then JavaScript became faster. With the advent of fast VMs like V8, applications that started rivaling desktop applications were now suddenly possible. And the applications grew to use this performance. So as all the VMs out there got faster and faster, the applications took advantage of that and became more complex. So we see this continual advancement and power hungriness of applications. So we don't see that ending. Performance is still important. Another reason why performance really, really matters is because of mobile. Now, on your laptop, you have a fairly large battery, or on your desktop, you're plugged into the wall. But on your phone or your tablet, you actually don't have that large of a battery. If you last a day, that might be a good day. And performance directly impacts that. The faster your application is, the less CPU it's using. That means the less battery it's using. Even a 10% increase in battery life is a significant improvement. So this really matters. And yes, so what we like to say is that every performance improvement is a battery improvement. Okay. So first, let's talk about Dart2JS here in terms of our tools. So as we said, the Dart2JS is responsible for compiling Dart to JavaScript. Quickly, the way this works is that we pull in your application and all the libraries it imports. We run it through all the optimizations and compilation steps that Dart2JS does to minify your application. And then we output a JavaScript file. That's the compiled version of your app. We also output a source map to enable really easy debugging, which maps the original Dart code to the compiled JavaScript code. And your Chrome Dev Tools can read all of that. So when you set a breakpoint in your Chrome Dev Tools, it's actually setting a breakpoint from the Dart code and mapping to the JavaScript code.
Which also works in browsers like Firefox and I believe IE. OK, so let's look at some of the generated JavaScript so you can see a little bit about what the compiler is doing. So here's a very simple example. We have a Dart program that's using the HTML library, and it defines a simple class person, and then it uses that class in some simple way in the main method. So here's some JavaScript output that the Dart2JS has produced. And you can see that it actually is very readable and kind of corresponds logically to the Dart source code. In fact, in this case, there's like a one-to-one kind of correspondence between the lines of Dart and the lines of JavaScript. But like we mentioned, Dart has minification, and it has treeshaking, which is dead code elimination. So it's important to produce the smallest application sizes as possible. So when you turn minification on, you can see that as part of the compilation process, we rename variables and inline functions and do interesting things here to give you the most compact JavaScript possible.
So Justin mentioned treeshaking. Well, what's treeshaking? So if you look at the marketing material of pretty much every JavaScript library out there, the first and foremost thing they tell you is how small it is. Instead, I, as a developer, care how good it is and how can it help me. Well, you shouldn't have to worry about how small the libraries are. You should let the tools handle that kind of stuff for you. Here's an example here. Here's an application. You've written the stuff on your left here, and it pulls in a library, the library in the yellow. And one of your functions calls just one function from the yellow library. And there's no reason why you should have to pull in all that baggage if you can determine only the functions or the features that you actually need in your app. Well, Dart2JS performs a tree-shaking functionality, which takes all the dependencies, all the imports, all the libraries, and can look at the program and say, OK, these are the bits you actually use, and produce just the code that is required to run your app. Notice how you don't have these kind of leaf nodes that you never actually call. This is another reason why Dart2JS can produce smaller, faster output for you.
Let's talk about the performance of the Dart VM. OK, so if you saw Lars and Casper's talk, they went into great detail about why the VM is faster. But real quickly, Dart has more explicit and static and declarative structure. This allows the VM to be braver and make smarter optimizations, and it allows the VM to be simpler. We have real arrays and real classes. You can invoke a method without having to crawl the prototype chain to see if the method has changed at all. So these things allow the VM to be much faster already. And in addition to that, we're able to use more of your CPU. So we've added SIMD extensions recently to Dart. And if you look at a modern CPU, a significant portion of the die is dedicated to these vector processors, these SIMD processors. This is an ARM CPU, and you can see that almost a third of the CPU is dedicated to the neon and vector operations.
Yeah, traditional web programming today cannot unlock the full capabilities of your CPU, and that's a real shame. And so the Dart VM says, yeah, let's give you this power.
So how does that performance actually manifest itself? Well, we have a few benchmarks that we've been publishing. And you can see the blue bar here is the Dart VM, and yes, higher is better. And so you can see on these performance benchmarks here that the VM has been beating handwritten JavaScript. And in fact, on the ray tracing example, it's almost 2 times as fast. And if you notice over here on the left on the Delta Blue benchmark, there are cases where Dart2JS actually produces faster code than handwritten JavaScript because of the optimizations it's able to make. So here in Delta Blue, Dart2JS is a little bit faster than JavaScript.
We should point out that Dart is not even yet a 1.0 production release, and we're still doing pretty good, but we have more work to go.
I think V8 has a 4 or 5 year head start on the Dart VM. Yeah. OK, now, Seth.
Oh, sure. Let's talk about this one. So the nice thing is these charts here are all running on this beefy MacBook Pro, right? This guy's got like 87 cores and 52 gigs of RAM. So of course, these numbers are going to look really impressive. But does it translate down to mobile, which is what we're all going to be developing by this time next year? So happy to say that yes, the same kind of performance characteristics when you use the Dart VM as opposed to handwritten code does translate over. So this is running on Chrome for Android with the Dart VM embedded inside on an x86 phone. You can see here the yellow is handwritten JavaScript. The middle guy is just Dart VM. And then the big, tall blue bar is Dart VM having ported the n-body simulation over to use the SIMD instructions. So every performance matters on mobile phones, because Justin said it's all about battery there. So you'll see the same gains even on the little devices here.
This basically covers what we have for you for new stuff, but there's so much more. There's a lot of things we didn't get to cover.
We asked for the 3-hour slot, and they didn't give it to us.
Yeah, the keynote. We could have
only
filled
one
the
of
keynote.
those. Okay.
So we have an entire server-side story with Dart. It's very similar to Node, and we have an I/O library. As Seth mentioned earlier, we have extensive testing libraries. We also have a concurrency and safety story in isolates that we didn't get to cover, and a lot more stuff. So you should really find out more about Dart.
How do you find out more about it? Well, in many different ways for you to try out Dart. Download the Dart SDK and the Dart editor from dartlang.org. We're active on Google+ and Twitter, etc. We're also on GitHub as well. So we've received many patches from the community and pull requests. We have external committers as well. We're active on Stack Overflow. And it's important to understand, Dart is an open source project, BSD license, very permissive. And so it's easy for you guys to get involved in any different way that works for you guys.
We've broken up a lot of the smaller projects into their own repositories on GitHub, and we've had a lot of external contributors come in that way because it's very easy to get started.
Lots more about Dart here at I/O. Later today, the Dart HTML talk, definitely check that out. We have a code lab on Friday, so if you want to get your hands dirty here working with all the latest and greatest, join us on Friday. We'll be at office hours as well, and the demo booth, you can see a lot of this stuff in action. So to sum it up, what's the main takeaway? Well, Dart, we've got a stable language now. We have a stable core libraries. Dart compiles a JavaScript and runs across modern browsers. And it's really been an evolved platform now. We've been out for, what, almost 2 years, 1.5 years? A while. We've gotten tons of feedback from external developers, internal customers, external customers. They've been telling us what they like, what they don't like. We put that all in. And so what you see today is a nice evolved platform. And Google is committed to Dart. We have internal high priority projects inside using Dart. And we're going to see this so that you can make it, or Dart is ready for your app. That's the main point here. Hopefully you saw what you liked, or liked what you saw. And we'll be around to answer a lot of your questions here. I think we can probably take 1 or 2 questions, but we'll be up at the office hours immediately after the talk. And we'd love to hear what you guys are building. So I think with that, we're all set. Thank you. We could take a question or two if anyone has any. OK, cool.
Do you think we'll see Dart on App Engine?
I would personally love to see that happen. There's a bug in the issue tracker for App Engine. Go ahead and star that and let them know. OK, thanks. We'll be around here. Thank you.